In this video, we'll implement strafing into our character controller. Currently, when our character moves, they turn to face the direction of movement. However, when strafing, we want the character to face in the same direction as the camera. With a third-person controller, this generally occurs when the player takes aim either down the sights of a gun, with the bow and arrow, being locked on to another combatant, and so on. In order to focus specifically on strafing, the base of this project is the character controller. That means this won't include the character stances if you've seen that video. I'm doing it this way to avoid people from having to watch a string of videos to catch up. This way, it's far easier to get the gist of how it works. If you want to implement both together, I have confidence in your abilities and I'm sure you can do it. To start, I'll import 5 new animations: standing walk forward, standing walk back, standing idle, standing walk right, and standing walk left. All of these animations can be found on Mixamo, and as always, you can substitute for your own animations to suit the context of your game and why they're strafing. I'm going to set some of the import settings, such as animation type to humanoid, avatar definition to copy from other avatar, and source to export avatar. Individually, in the Animations tab, I'll set Loop Time, Loop Pose, Transform Rotation bake into Pose based upon Original, Transform Position Y bake into Pose based upon Feet, Transform Position XZ bake into Pose if it's the idle animation, and based upon Original, then apply. Now, the next step is to update our animator. Currently we have one parameter, forward, which reflects how fast the character is moving and controls the blending of our base. We're going to change this one float parameter into 3. Strafing, the blend between regular and strafing movement, strafing X, the character's movement right, and lastly, strafing Z, the character's movement forward. Since our character only ever moved forward, we used a blend type of 1D. In order to properly blend our new animations, we're going to use 2D freeform directional, where each axis represents a different direction. We're using freeform over simple as it allows us to have multiple motions in the same direction. For our blend parameters, we'll set strafing X as our X-axis and strafing Z as our Y-axis. If you're a little confused, imagine that the graph is a top-down view of our character, where up is forward of them. You will notice that with the addition of our new animations, we'll have 2 idles and 2 walks. To accommodate this, we'll remove both the idle and walk motions. Then we'll add a new blend tree to our current blend tree and set name to idle, blend type to 1D, and parameter to strafing. Then add 2 motions, our old idle and our new idle, with thresholds of 0 and 1. We'll do the same thing for walking, and here you can see the blending of the 2 animations. Now we'll add the other motions, standing walk back, standing walk left, and standing walk right, and then I'll quickly reorganize them. Next, we have to position our motions. Fast run Y as 8, same as when it was 1D, and X as 0. Standard run as 0.6, walk forward as 0.2, idle as 0.0, walk back as 0.2, walk right as 2.0, and walk left as -2.0. This is what the blend tree looked like before and what it should look like now, with 4 strafing motions and the 2 running ones. Onto our player inputs. All I'm going to do here is add another input called aim, and in scene I'll set it to mouse 1 or right click. Now in our character controller script, I'll start by creating some new variables. Strafing and sprinting are self-explanatory. Strafing parameter and strafing parameters XZ are the values that we'll push to our animator parameters we made earlier. Lastly, I'll make a walk speed that represents the speed when we're strafing and set the value to be the same as the threshold values in the animator. I'll remove these old debug lines as I don't think we need them anymore. In this line, we rotate the move input vector by the camera planar rotation. I'm going to create a new variable called moveInputVectorOriented to store this, so we still have the original unaltered value. Then, I'll update both the new velocity and target rotation calculations to use the new variable so they remain unchanged. For the other instances of moveInputVector, it doesn't matter. Next, we want to determine if we're strafing or sprinting. They're going to be mutually exclusive, meaning we can only do one or the other, and we'll make it so the second input overrides the first. If we are strafing, sprinting is equal to the input.sprint.pressDown, and if the move input vector does not equal vector3.0. In other words, the sprint key was pressed this frame and we actually have move inputs. And strafing is equal to inputs.aim.pressed and not sprinting. In other words, strafing remains true if the aim key is held down and we're not sprinting. If we are not strafing, sprinting is equal to inputs.sprint.pressed and move input vector does not equal vector3.0, and strafing is equal to inputs.aim.pressDown. Now we need to update the move speed to account for our third speed. Instead of this condition, we'll replace it with sprinting. Then we'll create an else if strafing, copying and pasting the target speed calculation and replacing the sprint speed with the walk speed. In short, if sprinting, we'll use the sprint speed. If strafing, we'll use the walk speed. Otherwise, we'll use the run speed. All as long as we have some sort of input. For the translation, we don't need to do anything here, as we already changed the calculation to use the oriented vector. For the rotation, I'll create a new condition, if strafing. Then I'll copy and paste the old calculations and replace the move input vector with the camera planar direction. Lastly, we'll add the else here. So, if you are strafing, the character faces the same direction as the camera, otherwise they face the direction of movement. Finally, the last major thing we need to do is handle the animations. For the strafe parameter, I'll keep it simple and make it linear. If strafing, strafe parameter will be equal to itself incremented by time.delta time multiplied by an arbitrary 4, clamped between 0 and 1, meaning it'll take a quarter of a second to blend fully into strafing. Strafe parameters xz will be the vector3.lerp of itself and move input vector multiplied by new speed, with a lerp value of move sharpness multiplied by time.delta time. This is the reason why I created the move input vector oriented, so I can have the input vector unchanged, and where it still represents the direction of movement locally to the camera. If we are not strafing, strafe parameter decrements towards 0, and strafe parameters xz is lerp between itself and vector3.forward multiplied by new speed. Then we'll push these values to the animator parameters using animator.setFloat and their respective names. And while I'm here, I'll just round these values to the nearest hundredth by multiplying it by 100, rounding to the nearest whole number, then dividing it by 100. Now let's see it in game, and make sure you get the names right. Okay, so we still have what we had before, and if you right click, the character will start strafing. If I run towards the camera, then strafe, the character turns to face forward while still moving back. We can also see that strafing will cancel sprinting, and vice versa. Everything looks good, except for strafing diagonally. Looking at the animator, we can see that the strafing parameters go to 1.4. This is because the input vector is normalized and multiplied by the walk speed too, which produces these components. If you have the means, you can add additional animations at these points to help the blending, but I don't, so instead, I'll move the vector normalization down to here. Now diagonal movement results in components of 2 and 2, which in this case makes the blending look a bit better. And that's it for strafing. My example here is fairly generic, so make sure you adapt it to suit your needs and the context of your game. Thanks for watching, and if you liked the video or found it helpful, tune in for the next one.